Hi there, welcome back to the channel. In today's video, we are going to be discussing chemical bonding. Now, naturally, chemical elements do not exist in free forms. Most chemical elements, there are some which exist in free forms, and the ones that exist in free forms are basically noble gases. Why? Because they are stable. And the other ones exist in bonded form because they are unstable. Now, they exist in bonded form because the essence of existing alone is for stability. So because they want to attain stability, hence they bond with other atoms in different ways. Now, these ways in which they bond are the things that are what we want to study in under chemical bonding. Now, chemical bonding is just a way of interaction of atoms between one atom and the other to form a compound or a molecule, and that is very essential. Now, it should be noted that the currency of exchange in the realm of atoms are electrons. Now, how do they interact? Is either they share electrons or they transfer electrons. Now, an atom which has excess electron is going to have the capacity to transfer electron to another atom, and that is called electropositivity. That property is called what? Electropositivity. It is able to transfer because of excess electrons that the atom possesses. It's going to be able to transfer electrons to another atom, and that is typical of metals. It is typical of what? Of metals. Now, while there is another element, another atom rather, that is going to take electrons from this guy, and that guy is said to be what? That atom is said to be what? Electronegative. Negative. So the electronegative element is the one that is electron deficient and it needs some more electrons to attain stability. The essence of bonding entirely is to attain stability. Now, if the atom gives electron, it is electropositive and is going to get what is called a formal positive charge. Now, and this is very essential. It is a formal positive charge. And the atom, the species that takes the electron, is going to gain a formal negative charge. Hence the reason for why we call them electronegative and electropositive. You see, electropositive because it has high electron, excess electron, it can donate, while electronegative is electron deficient, it has ability to what? Attract electrons to itself, collect electron. Is that okay? And this is the basis of chemical bonding, either an electron transfer or an electron sharing. Hence, we have the following types of bond. We have what is called electrovalent bonding, electrovalent, or otherwise called the ionic bond. I'm going to explain why it's also called the ionic bond. Now, there is also the second, the covalent bond. Then there is also the dative or the coordinate covalent bond. Then there is also the hydrogen bond. And there is also the van der Waals forces, or you call them the London dispersion forces. The London dispersion forces. And then we also have the dipole-dipole interaction. Now, you see, for the purpose of this video, we are going to be examining only these two for today. We are going to be examining only these two. I want us to see the major differences between these two. All right. Now, let's go. What is the electrovalent bonding? The electrovalent bond, you see, as the name suggests, you see electro. Electro is got from the word electron. And valent means valency. Or ionic. The word ion, what is an ion? An ion is a charged atom. Now, how does an atom become charged? An atom becomes charged when it has interacted in one way or the other, either by transferring electron or by sharing electron. Now, when an when an atom transfers electron or accepts electron rather, when an atom transfers electron or accepts electron, it becomes an ion. It becomes charged, and that charged particle is called ion. Remember, Arrhenius principle says that when substance is dissolved in water, they dissociate into freely moving charged particle called what? Ions. So when an atom has donated or received electron, it becomes what? An ion. It becomes charged. All right, let's go on. What is the electrovalent bonding? The electrovalent bond is one in which there is a total transfer. There is a total transfer of electron. There is a total transfer of electron from one atom to the other. Now, it's usually from the electropositive metal, the electropositive element, which is a metal, to the electronegative metal element, which is a non-metal. The transfer of electrons usually happen between the metal and the non-metal. The metal is electropositive, hence it means it has much excess electron to transfer over to the non-metal, which has less electrons. So it's going to transfer electrons to this guy. Now, because of that, this metal gains a formal positive charge, and this non-metal gains a formal negative charge on ionization. Example of that type of bond is such one as occur between sodium and chlorine. Such one as occur between what? Sodium and chlorine. Now, how do they do this? This guy transfers this guy has one more electron in excess, while this guy needs one more electron to have what is called a stable octet. Now, an atom can either have a stable duplet or duet, or a stable octet. Now, for this case, these guys want to attain a stable octet. Now, a stable octet means having 8 electrons in their shell. Now, how does this guy attain a stable octet? This guy, by the octet rule, this guy has 11 electrons. It is number 11. So that's why it has 11 electrons. Is that okay? The atomic number is the number of protons, and which at the ground state is the number of electrons of an atom. So sodium has 11 electrons, and the electron configuration is going to be 281, meaning that what? It has one more electron than the stable octet. So what does it do? It wants to get rid of this one electron. While chlorine has, by octet rule also, has 8287. Now, it is stable here. It needs one more electron to attain its what? Its octet state. So it's going to collect this electron from this guy. And because it has collected electron, this guy, which has donated electron with the symbol Na, which is sodium, is going to become Na+, meaning that it has given out one electron, while this guy chlorine has collected an electron. It's going to become a Cl-. And this is what you get on ionization of what? NaCl. On ionization of NaCl, this is what you have. So this is showing that this guy is the one that has electron excess and has given it to this guy. Now, what does this mean? At this stage, this guy is now stable, having a total electrical configuration of 2,8. It now has a stable octet, while this guy has accepted one more electron and has a stable octet of 288. Is that correct? Is that okay? Now, let's go further. Now, what do you see here? That the bond, the compound that is formed, the compound formed is polar or polarized. How? Because it can, as it is here, it can ionize to what? Give what? Na+ and Cl-. So the compound that is formed is polar. And because it is polar, hence can dissolve in a polar solvent. A polar solvent such as what? E.g. water. Remember, water is also polar with a slightly negative charge and a partial negative charge and a partial positive charge. All right, so what do we have here? This, because this is a polar solvent, this guy being polar can dissolve in water, which is a polar solvent. All right, another thing is this, because it is polar, that polarity has given it some other ability. Another ability that's given it is electrical conductivity. Electrical conductivity. So these guys, compounds formed by electrovalent bond, can conduct electricity. Conduct electricity. Now, because they are polar, hence that is why it is possible to perform the electrolysis of brine, the electrolysis of this guy and H2O, the electrolysis of acidified water and compounds, other compounds like that. So, because they can what? Allow electricity to pass through them. Now, this bond formation is also a very strong bond, and because it is strong, it gives this guy a high melting and boiling point. Because of the strength of this bonding, they have a high melting and boiling point. And these are the characteristics of the electrovalent bond. Now let's show the electrovalent bond in an orbital atomic orbital diagram. So for example, we want to use that. So sodium, we said, was number 11. This is sodium 11, and chlorine, which is 17. Now, the electron configuration of this one is what? 281, using the octet rule electron configuration. Of course, you know that the electron configuration, the modern electron configuration is 1s, 2s, 2, 2p6, and 3s1. This is the modern electron configuration, but we want to use the octet rule electronic configuration. All right. So this guy is going to be 287. Is that okay? Now, what do we have? From here, we have that the K shell is going to be filled with 2 electrons. The M shell, the L shell, is going to be filled 1, 2, 3, 4, 5, 6, 7, 8. And then the last shell there is going to be having 1 electron only. Then for chlorine guy, we have 1, 2, the nucleus. Then the second shell is going to have 1, 2, 3, 4, 5, 6, 7, 8, just like this guy. Then the last shell out, the outermost shell, is going to have 1, 2, 3, 4, 5, 6, 7. Now, what does this mean? This guy has 1 more electron outside in excess, and this guy needs 1 more electron. It is deficit by 1 electron. So what does it do? There is a total transfer of this electron onto this guy, so that at the end of the day, what will be formed, NaCl, we have a configuration of an orbital diagram of this. This guy is going to have this. Now, this is stable. It's going to have when I introduced the video, I talked about the fact that the inert gases, the noble gases, are the stable gases. They are the stable elements. So this guy is going to attain a stable configuration, which is the configuration of neon. Is that okay? So you see, he's having neon having 10 electrons. This guy also have 10 electrons. So neon typically is equal to Na plus in number of electrons. Is that okay? Good. So, and this guy has gained 1 more electron, so it becomes this. 1, 2, 3, 4, 5, 6, 7, 8. And then the last shell also has 1, 2, 3, 4, 5, 6, 7, 8. With this one being the electron that I got from sodium. And this is what you have for electrovalent bonding. All right, then someone wants to ask a question. That what if we have a compound like magnesium wanting to react with chlorine, for example? Now, if magnesium wants to react with chlorine, what do we have? For magnesium, for example, magnesium is number 12. And that means that it has 2 more electrons more than it needs. 2 more electrons more than it needs. For example, we have here 1, 2. This is the orbital diagram, the atomic structure of magnesium. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8. That's 10 altogether. Then we have 2 more 1, 2. Now that's the opposite diagram for magnesium. Now, and chlorine, on the other hand, has this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last here, 1, 2, 3, 4, 5, 6, 7. Now, what will happen if this guy donates 1? If it donates 1, there will still be 1 left for this guy. So what does he do? This guy goes to call another chlorine that, hey, come here. There is a guy who wants to donate electron for us. And then the chlorine asks, but I need only 1 and you need only 1. How will he donate 1 electron for us? Then the chlorine will say, I have a guy that can donate 2 electrons. And therefore, this guy is going to donate 1 electron to 2 chlorine atoms. So we have this. Then the second guy here. So it's going to donate this electron now to this guy and donate this electron to this guy. So that is why we are going to end up with a molecule that is like this, MgCl2. Meaning that 1 magnesium donated electrons to 2 chlorine atoms. I hope that is clear. So that is it on electrovalent compounds. Notice, the compound is always between a metal and a non-metal. Magnesium oxide, aluminum oxide, aluminum chloride, magnesium fluoride, sodium fluoride, like that. That is the way electrovalent compounds are formed, usually between a metal and a non-metal. All right. Now, what about the covalent bond? Now, the covalent bond, now, from the word co and valency, right? Co means together. So for covalent compounds, now, how are they formed? I said co means together. The word co actually means together. So when you hear coordinate, it means organize a group of people and, direct them together. Whenever you hear the word co, it means to do together. So in this case, it's going to be that there will be a coming together, they are going to share their valencies together among each other. Is that okay? They are going to share their valencies amongst each other. Rather than being a total transfer from one atom to the other now, there's going to be a sharing of that valency, of that electron between the 2 atoms. And this is essentially how molecules are formed. These are what? Molecules are formed. So an example, let's talk about some of their characteristics first. So we said that there's going to be a sharing rather than what? Total transfer. Sharing of electrons. Now, and this concept happens between non-metals only, not a metal and non-metal. So it's like when the non-metals do not find someone to dash them electron, to give them electron, what do? Then they look for a mate who has more electron, who has the same problem as them, and then they decide to cohabit, so that sort of thing. So it happens between non-metals, all right? So for example, if oxygen, for example, doesn't find a suitable partner who can donate electrons, so what does it do? It finds another oxygen and comes together with that oxygen, and they bond covalently. They share their electrons, and I'm going to show you how in just a moment. Now, what does this mean? If it is between non-metal and it involves a sharing of electrons, it means that they cannot, they don't ionize, isn't it? And because they don't ionize, it means they are what? Non-polar. It means they are not polarized. So they are what? Non-polar. And because they are non-polar, it means they cannot dissolve in what? Polar solvents. Cannot dissolve in polar solvents. Which means they can only dissolve, of course, in non-polar solvents, of course, such as benzene, hydrocarbons, toluene, oils, etc. So that is what they can dissolve in. Now, the next thing is that since they are not polar, it means that the bond, the covalent bond, is not as strong as the electrovalent bond. It's not as strong. So because it's not as strong, they have what? The bond is weak. I said electrovalent bonds are strong, while covalent bonds are what? They are weak. Now, covalent bonds are weak and they give that molecule formed a low melting and boiling point because it is melting and boiling point. So because it confers some degree of weakness on that molecule because that bond is not as strong as electrovalent bond. Now, the next property is that since they are non-polar also, it means that they will not conduct electricity, cannot conduct electricity because they are non-polar, cannot conduct electricity. All right, so these are some of the characteristics of the compounds that are formed covalently. My example is the N2 gas, the O2 gas. Notice I'm writing molecules in most of it. Cl2, H2, those are covalently bonded substances. Now, how do they bond? Let's draw their atomic structures and see how they are bonded to one another. So, for example, let's use the nitrogen. Let's start with nitrogen. Now, nitrogen, for example, is number 7, so we have N7. Now, N7 is going to have, by octet row, the configuration 2, 5. Is that 2, 5? Now, how does it bond? Since it needs 3, it needs another substance, another element that can donate 3. But since it has not found one, it's going to look for another N7 that also needs 3. So what it will do is it's going to bond, these two ends are going to bond by sharing their orbital, their electrons, and see what they are going to do. So this guy has this as the atomic structure 1, 2, 3, 4, 5. All right? Now, let's position this to here. 1, 2. So 1, 2, 3, 4, 5. This other guy, the same thing. 1, 2. So they have similar problem. So what do they do? Then this one asks this guy, how many electrons do you need? Now he says, I need 3. And this one says, how many electrons do you need? I also need 3. Okay, so what do? Give me your 3, and I'll give you my 3 as well. How is that going to be possible? That one says, we are going to hold together the 3, so that when we are asked, where are your electrons? Are you stable? Yes, I'm stable. Then I'm going to show some of your own electron and my own electron. All right, let me show you how that is going to be possible. Now, what they do is this. This guy is going to come together with this guy, and you have this. You are going to have this. This guy is going to bring his own 3 electrons here. Since this guy needs 3 electrons, and this guy needs 3 electrons, this guy will bring his own 3 electrons, 3 of these 5 outermost electrons. Is that clear? 3 of these 5 outermost electrons. He brings it, and this guy also brings 3 of its own outermost electron, so that they share this together. Then the duplet is untouched inside. So how many more? If it has shared these 3 and this one has shared these 3, how many more does it have? It has 2 left. 2 left. Is that okay? So both of them are stable technically. Let's check. These are the shared electrons. These are the shared electrons. Now, and they are stable now, technically. Look at it. This one has 2, and let's see if it has a stable octet outside. 1, 2. For this guy, 1, 2, 3, 4, 5, 6, 7, 8. And for this guy outside, this guy has 1, 2, 3, 4, 5, 6, 7, 8. And that is what a stable octet for both atoms. And this is how N2 gas is formed. So the same way for oxygen, oxygen is going to share only 2, 2. You know, oxygen is number 8. So, because it has 8 protons and the ground state 8 electrons, so it's going to share only 2 of the outermost 6 electron pairs. There's 3 electron pairs on the outermost electron. So it's going to share only 2 of those with another oxygen that needs 2. So that oxygen will also share 2 with this oxygen. And then it's going to attain a stable octet. And this is it for chemical bonding on electrovalent and covalent bonding. In the next video, we're going to be talking about the remaining types of bonding, which are the now the coordinate covalent is not so different from covalent, but the only thing is that rather than both of them contributing electrons, only one atom is contributing electron, but they are sharing the electron. Is that okay? Only one species contributes the electron, but they are sharing the electron. All right, we're going to discuss the intermolecular forces, which are the other types of bonding or forces that exist between molecules between molecules. So if you did gain value from this video, do want to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. See you in the next video. Thank you.